Hello, everyone. What we're going to do today is we're going to talk about limits, and a specific limit I'm going to start with is the limit as x approaches 2 of x cubed minus 8 over x minus 2. Now, one of the things we always talk about, try and plug in the number. If I plug in 2, what's going to happen here? If I plug in 2, I'm going to get 8 minus 8 over 2 minus 2. That gives me 0 over 0. Now, that doesn't mean the limit is undefined. That doesn't mean the limit doesn't exist. That means this limit is indeterminate. And indeterminate means we just can't determine the limit the way it's written. So what we're going to do is we're going to do two things. We're going to go to a graph, and we're going to take a look at the limit as x approaches 2 from the left-hand side. Everybody see that negative that's in front of the 2 there? That's indicating this is a left-hand limit. Okay, and that just means we're going to look at values from the left-hand side, from the negative side. Okay, we're also going to look at the limit as x approaches 2, and we're going to put a little plus symbol out there after that too. It just means we're going to look at the limit from the right. Okay, this is a right-hand limit. Okay, so let's take a look at the graph of this function. Now we know, if you look at Desmos here, Desmos is a great tool to use when it comes to doing anything math related. I have graphed this function, and it's funny, it looks like a parabola, but there is a hole right here at 2. Now, what we're going to do is we're going to take a look at the values as x approaches 2 from the left-hand side. So I'm going to start on the graph over here, and this doesn't really mean much because I'm pretty far away from x equals 2. But as I get closer to x equals 2 over here, closer and closer to 2, those y values seem to be approaching 12. Okay. So if I go back here, the limit as x approaches 2 from the left-hand side seems to be approaching 12. Those y values were approaching 12 on that graph. Well, let's go back and look at the right-hand side. If you guys take a look at the y values as I get closer and closer to 2 from this side. Okay. About 1/100th away. Notice as I get closer and closer from the right, those y values seem to be approaching 12 as well. So it seems to me like the limit from the right-hand side is also going to be 12. Now, here's the great thing about limits. If both of these are the same, if the left-hand limit actually equals the right-hand limit, then we can talk about the value of my two-sided limit, which is just written, the limit as x approaches 2 of x cubed minus 8 over x minus 2. It seems to me the answer to this limit is 12. Now, we're going to confirm this from a table. You'll notice on Desmos here, we've set up a table. X cubed minus 8 over x minus 2. I'm going to let c equal 2. And what this table does, it takes c equals 2 and plugs it into the original function. And we can see that it's definitely undefined, just like we found before. It's 0 over 0. So now it takes 2 and subtracts 0.1. So this is at 1.9. The value is 11.441. Take 2 minus 0.01. So at 1.99, the value is 11.94 approximately. If you take 2 minus 0.001, 1.999, the value is 11.994 approximately. Now, what can we say about these y values as I'm getting closer and closer to 2 from the negative side? It looks like they're approaching 12. And as I zoom in on this graph here, you can see these points. We'll get to the point where I can see all three of them. Here is 0.1 away, 0.01 away, and right here is 1/1000th of a unit away. And you can tell those y values are getting closer and closer to 12. So just like I wrote here in the red, it looks like the limit as x approaches 2 from the negative side is actually 12. Look at the table again. We're going to go to the right-hand side. 2 plus 0.1. Comes out to be 12.61 for the y value. That's right there. If I take 2 plus 0.01, I get 12.06. That's right there. Now notice again, these y values are getting closer and closer to 12. And that last one, if I take 2 plus 0.001, I get 12.006001. If you look at those y values as x approaches 2 from the right, looks like they are also approaching 12. So the right-hand limit is also 12 in the table. So if the left-hand limit again is 12, the right-hand limit is 12 from your table, the two-sided limit is going to approach 12. So we looked at the graph, determined it was 12. We looked at the table, determined that the limit was 12. Now the other thing I've got to be able to do is do this algebraically. So I'm going to take the limit as x approaches 2, and I'm going to take this function and I'm going to factor it. This is called factoring and canceling. Now, the top is a difference of cubes. It's actually x to the third minus 2 to the third. And if you know your factorization methods, that factors into x minus 2 times x squared plus 2x plus 4. Now, since I plug in 2 and it gives me 0 over 0, here's what you're going to see. Those x minus 2's right there and there are going to cancel. Well, x minus 2 over x minus 2, if you plug in 2, you get 0 over 0. So we are technically canceling out the 0 over 0, which allows me to basically try this limit again. I'm going to plug in 2. I would get 2 squared plus 2 times 2 plus 4. Well, that gives me 4 plus 4 plus 4. And what do you know? Even algebraically, the limit comes out to be 12. If you like this video, please hit the like button. Maybe subscribe to my channel. I'll be posting more videos about calculus and other math topics in the near future. Have a good day, everybody.